Всем привет. Давайте продолжим.
Hi everyone. Let's continue our discussion today. And we're going to talk about the testing, the capacity and performance of the iOS application with the support of Xcode instrumentation tools. My name is Vitaliy. I'm working with the iOS application, and I'll share my experience how testing is done with the help of Xcode tool test kit. First, I'll tell you about what performance parameters of an app is, how is it tested, what are the indicators to test them. The first version of iOS and the first iOS device was released in 2007. At that time of the year, the developers were trying to develop functional applications, but performance was not paid much attention to because it was essential to take up the market niche. And functionality of apps were not that relevant. However, times were changing. New functions appeared, and now we're at the beginning of 2019, and App Store accounts for more than 1 million available apps. So your apps have to be both functional and productive, because if your app has low performance, then the user will just delete it and install a competitor's application. To avoid this, one has to pay attention to the performance of your app. Performance of an iOS app is a combination of such features as the time to start up their central processing unit, the time of response to the user's actions, and their operational memory consumption level and battery consumption time. An app is considered to be productive and have high level of performance if it combines all these 4 parameters. For each user, a well-performing app means different things. For some of the users, it's an app that uses little operational memory, or an app which doesn't consume battery. I'll tell you how to measure all these parameters. Though before we start testing, we have to first decide how we are going to test. Are we going to use a simulator, or are we going to use a real device? The difference between the two is that the simulator only simulates the software, but doesn't simulate hardware. Because of that, you might have a situation that on the simulator your app runs very fast, there are no problems, but when you have it installed on the real device, problems appear. To avoid such situations, I advise you to do the tests on the real devices. In our company, we established the testing procedure in such a way that we are testing the memory operational consumption in the simulator, but the other parameters are being tested on the real devices. We select them based on the target audience and devices which our users most commonly use. We're trying to select such kind of devices which are less productive. We focus on the target audience with their total share of the potential users of 5% or more. Once we made a decision what we're going to test on, we have to analyze an app to understand what functionality it has, what networks are being used, GPS modules are being used, whether the users utilize Bluetooth. So we actually make a map of functionality. After that, we prepare a checklist. The checklist is different for each performance parameter. When drafting such a checklist, we include certain cases. If we create a checklist for the CPU, then create the certain check cases for the CPU. If we create a checklist to test how the operational memory is consumed, we include test cases to check all the possible options to check how the memory is being consumed, such as the screens with a lot of animation, with a lot of content, or pictures located on the screen. If we test the feedback time, then we envisage that the test case includes a screen with a lot of graphical items. And while testing the memory consumption, we're trying to use as many cases when the networks are using as possible, whether the user could use a GPS model or a Bluetooth or GPS, whatever. So it means during the test scenario, all these modules have to be on and have to be tested. Once we have comprised the checklist, we install or make a copy of an app to a MacBook, because I'm using a MacBook actually, so that's why I'll be talking about using MacBook, and make a connection of your device to a MacBook via a cable and install a test bill on a device. In my presentation, I'll only talk about all the parameters I mentioned before and the testing based on the real devices. If you follow the barcode, you will read more information which I had prepared. Let's talk about the testing of the CPU. CPU test time gives us a possibility to test how the functionality affects the performance of the CPU. Testing starts as follows. After you have installed and connected the build, you set up an Xcode in the section Open Developer Tool. You find there screen instruments. Then you will see a screen with a list of available tools. They are available both for testers and platform developers. These are iOS tests to test and profile your apps. I'll tell you about some of them, and the rest of the information is available at the website developers.com. So to test the CPU, we are using the tool which is called Time Profiler. To set up this, we just click twice, and then a new template comes up. The template is very similar in terms of structure for other test tools. In the top right corner, there's a block which gives the additional information menu. These are sections 6 and 7 in the lower part of the screen. You can use them to profile the information and get additional information. Block 2 in the left top corner, these are the buttons to manage and control the testing, like to pause or start up. Block 3 indicates the route to an app, and block 4 it's a timer and the meter, having information about what kind of measurements you are making. If needed, you can later scroll it down and analyze the data. Block 5 looks like a set of graphs containing information how the CPU is being loaded, and mainly blocks 6 and 7 contain additional information. I'll show you later what additional information is available in these two blocks. Profiling process starts with the launch of the instrument. You start the button, pressing the start button. After you launched it, you start to perform test cases. When doing testing of the cases, you should follow the trends on the diagram, and you can test how CPU performs during the certain testing scenarios. These tools also gives you a possibility to see information in a diagram about their downloading for each segment of the process of the CPU. I made these slides of my presentation in the 6 nuclear CPU. So that's what it looks like. But we have to test the download process on each of the nuclears. And we have to try to reach the ideal situation, which is when all the functionalities perform, each nucleus is downloaded symmetrically. If there is the overload, it means that your app requires optimization and one of their nucleus is not working properly. Such problems have to be corrected and will ensure faster performance and faster productivity of the whole CPU. As I told you, if you need to get a more detailed information, which method you use and which operation requires more resources, you can just open the additional information menu and after opening up all the methods, click and the next code will explain what problems are caused by each of the methods used. Such tool is used, and I recommend to use it if you know that your app is complicated in terms of functionality. Also, it is advisory to understand before the release of an app what will be the load on the CPU, so that you could evaluate that your target audience, irrespective of the device, will feel comfortable when operating your app. Another example from my own experience is an app. It's a photo editor. We had a problem where there is a section with the filters. There are more than filters available for the users, and when pressing that section for more than 3 seconds, the app was not reacting. Later on, we discovered with the help of test case, the CPU could not catch up with processing the picture because there were more than 50 filters available, and that was the reason why so much time was spent and why so much time was a waiting time. And we managed to change the logics to the approach with the support of our test tool, and we were able to correct such a bug, and we do not longer experience this problem.
So let's talk about the next parameter, which is the response time testing. I mean the response time to the user's actions. So it means the speed with which the picture is formed at the display when the user does something. Why should we do that? In order to optimize your application and the central processor load. So you've done it, but also during the real work, during operation, it takes time to form an image on the display. So the application in its interface looks not user-friendly. So this is the problem with the graphic interface. And in order to test this parameter, we can use this test environment. So you just find the instrument, you launch it, and then you perform a case, run a test case, and when you do it, you make the same verification. So you just check the speed of image generation. The speed of image generation in iOS is measured in frames per second. The optimum is 60 frames per second. During testing, you analyze the graph, so you check the speed of the image generation, and then in the menu of the additional data, you can check what was the speed of this action. And here you see various values, like close to 60 and lower values. So why there can be lower values? It's sometimes when just the processor cannot do it in a short time because he has to prepare a lot of images. It takes time. Also, he spends it spends a lot of time to calculate the interface of the tabs and etc. So using this instrument, you cannot localize, same as like with the central processor load, which is the process which overloads the processor. So that's why it's reasonable to check it in parallel, so to understand afterwards which action exactly caused the low speed. And when you know that there is a lot of graphics on the display and you have lists with images which require a lot of time for processing, and or if you have some low performance device, then also you can check it with this instrument. So another example from the practice, for example, we have an application which is actively used and it has motivations feature. It's the list containing list of motivation like posts. It's a short list with around 50, and in low performance devices there was delay of rendering, and the application was just stalled, was down, and it spent a lot of resources to render the gradients at the background. And then when we upgraded this feature, the problem was gone. Next parameter we're going to discuss is RAM testing. So what exactly can we detect with this tool? Normally there are two types of problems. First, when in the memory there are objects which the application doesn't need, but the links are still there and it consumes the memory. Another problem is so-called memory leak, when the objects are there but there are no links. So let's talk about the first case. So in order to detect these problems, we make this testing. So we just launch an application and then we look at the memory use. And so the memory use can be separated into phases. In the first phase, you can check how much memory this or that case consumes, and also you can check for the peaks of memory use during the time when you actually do nothing. And also you can check in which cases the most memory was consumed. After you detected the most problematic cases, most problematic spots, you can go on to the next phase when we run this test several times, 5 or 6 times. And the optimum case is when the starting point, you start from the starting point and then you get back to it, like making the full cycle. So the memory use should be the same as in the first phase. If there is increase in the memory use, then there is probably some memory leak. And what can be the consequences of that? So if users use it for a long time, they will just lack memory. To avoid that, it's necessary to make this testing using this tool. And the point of testing in the second phase, we use integrated mark generation tool. In the bottom of the screen, you see it. And so with this tool, before the test case, you put a flag. At the top, you see in the block number 2. So this is the initial starting point, and then you run test and after running test, you set another flag, and that's how you do it. Like you can repeat same case 5 or 6 times. Like this, you set test points for the memory use, and that's how you check how memory is used. And this graph shows how different is the current memory use from the previous periods, and it can be why it can be high, because it sometimes it's not a problem, just the system consumes a lot of memory. You can also see it here, and also you can analyze data. So you can open up every dimension and see which of the methods contains links to these objects, and then you can go to export, clicking on it, and that's how you detect the problem and choose the method for optimization. And another problem is when you have crashes during testing, when you get reports about emergency closing. And even if you don't have these problems, I recommend before release to check the memory use, because sometimes the memory use can be not too high, but if user uses like it's quite intensively, then there can be some cases when it's quite high. Then the second problem that we have to detect with our tool is the memory leak. Memory leak are the objects which can be stored in the RAM of the device, but which application doesn't need, and this is just the lost resource. This is quite a common case, and to detect this problem, we use leaks tool. The mechanism used here is as follows. So you also run test cases, and what is different from the previous scenario when you have to check the levels, here you have to check the second line. Look at the slide, please, where it's just stated whether the memory leak is present or not present. So the gray color means that there is no memory leak. Red color means that memory leak was detected, and the blue color means that the test has to be rerun. And here you can also click here, and you will see the list of objects containing some problems. So here you will see the list of problematic objects, and which have some memory leaks in it. And then you can also choose the method to optimize this or that module or site, and recommend to the developer to use it. So this instrument can be used in case of crashes, or also to verify that whether you have any problems. So this is an example from the practice. So we developed one application, and at the testing stage everything worked well, but after the release, some users, after 2 or 3 weeks, so there have been several crashes connected with insufficient memory. And when we looked deeper into this problem, we understood that each action caused creation of an object which had to be deleted from the RAM when it disappeared, when it went beyond the screen. And and if users were active and they achieved some higher levels, then it consumed too much memory and it crashed. And the last case is testing of battery consumption. Every user which has a mobile device wants to make the periods between charging cycles to be as long as possible, because not every user has access to charger all the time. So that's why if the battery doesn't last long, then the mobile device will just be discharged very quickly. So that's why we have to check how much battery the application consumes. Normally, battery is consumed by GPS, graphics, networks, Bluetooth, graphic interface, GI, and all that consumes battery quite actively. And if you know that your application is gonna use all these modules, then this is already a reason to test the battery.
To test the consumption of the battery, there's a tool called battery law. So the tool is used to go through the test cases. I advise you to split each cases into parts and analyze the case separately. This tool helps you to get the information about consumption of the battery by each module. That could be a Wi-Fi module, it's a graphical module, or a Bluetooth module. Also, the brightness of the screen can be tested separately here, and this tool collects this information separately for each part of the test code. Xcode developers measure battery consumption level in a range from 1 to 20. We did some experiments and found out that the level is assigned depending on the consumption. So the level of consumption is comprised out of the consumption of the battery by each of the modes. We were not able to find how Xcode measures that, but we made some experiments to test, and based on examples, we established such kind of measurement range. Memory consumption and battery consumption level could be tested via online and recorded as well. This method is very convenient if you want to test the level of battery consumption in the sleeping mode. This happens at 9 when the app is closed down. You can also test how the app behaves on the road. What happens if there is a change of the connection of the networks when the user, for instance, is traveling by underground. There is also a possibility to test in such a way that a record could be made, and you can record all the measurements. After that, you test it, and once you know that all the networks have been tested, you enter the device, switch off the device, and connect your device to the working station and import the data via cable from the device, and then you can analyze all the results received during the tests in the same way as you could do it online. Battery consumption testing is recommended to use, and I do it, when I know that my app will be extensively using Wi-Fi, Bluetooth, GPS, graphics, or sound. If I know from the beginning that I'm going to use a lot of graphical things or a lot of video, then it is recommended to test the battery consumption. We had an experience when users complained about fast battery consumption, and when we tried to analyze the problem, we found out that the rate of battery consumption was 8 out of 20. Then we detected that the high level of subscription validation was very high, and then we changed, after revision, the logics of the subscription validation, and the battery consumption level changed from 8 to 4. Summing up, I'd like to say that before you start performance testing, you have to understand that it is quite a time-consuming process. It takes a lot of time to prepare for the test. It takes a lot of time to analyze your app list. And I really advise you to create checklists in advance and discuss them with the developers. Because you may know your app from the point of view of a user, but developer knows from the point of view of a developer, and he can give you good advice what you should pay attention to. The second important issue is that you better use the real device. Then you will be able to simulate the environment, a real environment, which the end user will face with. And performance testing doesn't end by the fact that you simply hand it over the report to developer. What we usually do is that we come together with the developers and analyze in detail what the problem is and how this problem could be solved. So it does take time. That's it for today. As always, dear participants, you can win a t-shirt and your questions are welcomed. Hello, nice to meet you. Thank you for the presentation. How are you planning to do the tests and checks? When you are planning your tests, are you doing such kind of tests before the release, or do you test each feature on the battery consumption level, or etc.? How do you actually do it? For every stage of an app release, we know what functionality we are going to release, and when we implement the first build, we do mandatory testing. And if I know that we are going to implement certain additional functionality, which might be energy consuming or which might be really complicated, we also plan time for testing. If we know from the start that we are going to add certain graphical items, we need to plan more time for testing. If we know that we are going to change the logics of the requests, which might affect performance of the battery, we also plan in advance the time for testing. But what we do first is that we analyze together with the developers all the functionalities. We try to analyze the interdependencies, what could affect what, and then plan time for tests. Thank you for your presentation. Do you have your own assessment of builds? It is clear that it could be a number of indicators or a number of parameters such as the CPU, etc. Do you test checklists manually, or do you use automatic tests? Well, we don't do it manually. I already know that if I'm testing a battery and the device gets overheated, clearly it indicates the battery problem. But as you said, there are a lot of data which you collect to be able to assess the build. Have you got the assessment mode? Have you created this assessment or evaluation? I need to clarify. You mean to evaluate whether their app is productive or not? Yes, to test whether the build is good or not good as compared to the other ones. Well, I actually compare all the parameters. If the battery consumption remains with the range of 3 to 4, then it could be released for production. If there's no memory leaks, then the build is also good. I also check their memory consumption level and analyze it. I analyze the battery consumption level, and I try to analyze if the similar apps in the same niche use the battery the same way. Then we are analyzing it together with the developers, and we're trying to compare this. We are also analyzing what is the memory amount used on the devices by our target audience. And we're trying to test how the target audience behaves. Good afternoon. Thank you for your presentation. Do you share your checklist with the developers so that the developers test themselves when they're making corrections to the initial old version of the functionality? Developers in my team also perform monitoring of the battery consumption level, but they do not detect memory leaks. We try to share the areas of responsibility. I'm responsible for one part, and developers are analyzing only their surface problem, but my responsibility is to detect any deeper problems. Good afternoon. Thank you for the report. My question is the following. You have brought certain examples how you start the test of an app, but once I had a case, I installed an app. It was quite a famous one. It's the step measurement app. And when I was going to even change the battery in my iPhone, it turned out that the app, which was not even active, really ate up the whole battery. How could developers detect such a problem that an app, which is not even started, really consumes the battery? Well, I think they could have detected this problem with the support of this test tool. They could have recorded information, and it would become clear for them that their app really uses the memory on the device. But the question is whether the developers were thinking that such problem could emerge or not. Good afternoon. My name is Alexandra. I work for the company Renaissance Insurance, and I have a couple of questions. Could you please share with us what simulator you are using, and have you got your checklists available publicly, and how we are testing iWatch app? We do not have open checklists available because checklists depend on an app. Checklist contains the information about the functionality of an application, and it contains a list of the functionalities which will be most often used in the web. They will be covering most often used parameters such as the battery consumption, memory consumption, and other parameters. So there is no uniform, there is no tailored solution, there is no tailored checklist which could fit to test all kinds of apps. That's why we are developing our checklist for each app separately. As regards the question to the simulator, we're using the simulator which is built in the Xcode tool. And our company is not developing an app for iWatch, so therefore I cannot answer this question. Thank you for the report. Could you please tell us how you localize the problems relating to the battery consumption, and what is the most often reason of the battery consumption? Once you get the trend diagram, each model will be linked to information how much battery it consumes. And in the diagram, you'll be able to see the battery consumption level at the It is marked in different color. Also, there is the percentage rate of the battery consumption. There is the status low, high level, low level, etc., providing also the percentage of the battery consumption level. In our case, the one of the problems that led to the high battery consumption is the requests.
So I have a question. What is the principle of selection of cases to test the load, to test the productivity? Because some companies, what they do as 20% of the actions generate 80% of loads, so they select the most frequent actions, for example. Or some other companies, they try to select the heaviest queries. And what do you do? Well, in our application, we use highly loaded cases, producing the highest load for their device. When we have a lot of calculations, and because there are some calculations for fitness using the user's personal parameters to calculate the diet, and etc. So the calculation is the highest load. Also, there are cases when, for example, there is an application which uses some external data, like data from the external devices, Bluetooth, and when Bluetooth module is used intensively, so the load can be quite high. Hello, my question. So, do you have some reference device to understand that in principle everything is okay, for example, some baseline? And also, we know that there are newer or older versions. Is metric different for newer iOS and older iOS? But I think reference is 6 plus iPhone. If it works fine with this one, then everything which is higher or more advanced will also work well. So we tested it with iOS 11, and this is the highest version. Higher than that, we cannot test. 2 more questions, and we will finish. Did you ever have cases when you could not initialize the problem using this code? No, we didn't have such problems, just one time, but our developer had to settle this issue. He was debugging that, he was initializing every library to understand which of the libraries consumed most of the batteries. So that's how he localized the problem. One more question about the devices. So you said that iPhone 6 Plus and iOS 11 are the references, and you also said that you also make load tests for low productive devices, and you said that sometimes these devices don't support the most popular iOS, but do you try to support the most popular devices and iOS, which are most popular among your users? Is it your logic? Or no, we are trying to focus on iOS 11, and our target audience are people using iOS 11 or higher, and the target audience whose version is 10, I don't remember, it's only 1-2%. So we do not support that. We don't spend our time on that. I don't hear the question. Yeah, we support it on the devices like iPhone 10, 12, so we can run these tests. And it depends on time, on the load. I can test it on iPhone 10 to understand the difference between low performance and high performance devices. What will be the difference between them? So that's actually it. Thank you for active participation, for so many comments and questions. Thank you for your interest to the topic. Thank you, Vitaliy, for your presentation. And it would be really good if you select one question winner who will get a t-shirt for the best question. So this lady who asked several questions, you. Yeah. My congratulations. Thank you. So now it's lunchtime.